Okay, good morning students. Last time for a couple of days we tried to discuss about the different applications of integral calculus. Under this chapter we have seen about 6 different applications of integral calculus. The first one is the application of integral calculus to find area of a region. The second one to find volume of revolution of solid figures. And the third application of integral calculus is to find the work done by a variable force. The fourth application is the application of integral calculus to find equations of motion of an object. And as a fifth stage, we have seen the application of integral calculus to find average value of a continuous function over a closed interval. And at last, we have seen the fundamental theorem of calculus 1, which enables us to find the derivative of a function that is given in integral form. Now, after saying this much about what we have discussed last time, today we'll try to see the 6 units of our course, Unit 6. It is titled as Unit 6, 3-dimensional geometry and vectors in space. And the first subtopic of this chapter is about coordinate axes and coordinate planes in space. As you know, a space is determined by 3 mutually perpendicular lines which are known by the name axes. And these axes are named by the x-axis, the y-axis and the z-axis. These are the 3 perpendicular lines that determine a space. And when we design a space, we conventionally draw the axis in the following way. The positive x-axis is the ray that comes out of the page, in our case out of the board. The positive y-axis is the axis that is directed to the right, and the positive z-axis is the axis that is directed upward. And opposite directions to this are the negative values, negative x-axis, negative y-axis and negative z-axis. So using these 3 axes we can determine a space. And any two of these axes form a coordinate plane. For example, the x and the y-axis together form the xy coordinate plane, the x and z-axis form the xz plane, and the y and z-axis together form the yz plane. Therefore, we'll have 3 different perpendicular planes. Now, these 3 perpendicular planes partition the whole space into 8 parts, and each part is known by the name octant. And the different octants together with the corresponding signs are given in this way. Octant 1, under octant 1, every pair, every ordered triple has positive coordinates. Octant 2, its x coordinate is negative, y coordinate is positive, z coordinate is positive, and so on. From octant 1 up to octant 4, the z values are positive. That means they all lie above the xy plane. When you come to octant 5 up to octant 8, their z values are, if you see, they are negative. That means these 4 octants lie below the xy coordinate plane. So these are above the xy plane, these are below the xy plane. We have 4 above, 4 below the xy plane, and we'll have a total of 8 octants. Now, exercise 1 says, in which quadrant does each of the following points lie? For example, A, negative 3, 1, 2. Its x is positive, y and z are positive. X is negative, y and z are positive. X is negative, y and z are positive. Therefore, that point must lie on the second octant. So based on this, you can determine the quadrant or the octant where B, C, D, and E lie. The second subtopic of this chapter is about coordinates of a point in space. Any point in space is determined by an ordered triple of the form x, y, z, where this x refers to the direct distance of the point from the yz plane, y refers to the direct distance of this point from the xz plane, and z refers to the direct distance of this point from the xy plane. For example, if you look at this point, -2, 3, -4, it means this point is 2 units away from the yz plane, 3 units away from the xz plane, and 4 units away from the xy plane. So this is the meaning of ordered triple. Now here we have a list of problems in exercise 2. The first one is about plotting. You can plot each point. And it says the second one is find the distance of this point from the xy plane. The distance of this point from the xy plane is obviously it is x, it is z coordinate. From the xz plane is the y coordinates 5. And the yz plane, from the yz plane it is 2 units. Now let's pass to the third subtopic of this chapter. It is about distance between 2 points in space. If you have given 2 points P1 and P2 with coordinates x1, y1, z1 and x2, y2, z2, the distance between these 2 points can be found by this formula. D equals the square root of change in x square plus change in y square plus change in z square. Particularly if one of my point is the origin, so the distance of any point P from the origin will be given by the formula D equals the square root of x square plus y square plus z square. And when we come to distance of a point from the axis, we'll have the point P with coordinate x, y, z is at a distance of a square root of y square plus z square from the x-axis, and its distance from the y-axis is a square root of x square plus z square, and its distance from the z-axis is a square root of x square plus y square. So in this way we can find the distance between any 2 points, the distance between a point and the origin, and the distance between a point and the x-axis, the y-axis, or the z-axis. So by this we come to the end of this discussion. Let us continue our discussion from exercise 3. It says find the distance of this point from the origin. The distance of this point from the origin is the square root of x square plus y square plus z square. Distance d from the origin is the square root of x square plus y square plus z square. My x, y and z are 2, -1, -2. 2 square, -1 square, -2 square. So you have the square root of 4 plus 1 plus 4, that is 9. Square root of 9 is 3. So the distance of this point from the origin is 3. From the x-axis is the square root of y square plus z square. From the x-axis is the square root of y square plus z square, the square root of -1 square plus -2 square, that is 1 plus 4, 5, a square root 5 units. Its distance, you can find its distance from the y-axis and from the z-axis. From this point P, from this point Q, we score -1, 3, 10. Distance between 2 points is given by the formula the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Then after it will be a matter of substituting numbers in place of this. Now we'll have -1 minus 2, -1 minus 2, 3 minus -1, -1 minus 2 the whole square plus 3 minus negative 1, that becomes 3 plus 1 square, plus z, that is 10, 10 minus negative 2. 10 minus negative 2, it becomes 10 plus 2 square, and so you'll have here minus 3 square 9, this is 4 square 16, 16, and then 12 square 144. And that is 16 plus 144, 160 plus 9, 169. The square root of 169 is 30. Therefore, this point is at a distance of 13 units from Q. And the distance of this point from the xz plane is its y coordinate, absolute value of y coordinate, and that is 1. Now, let's pass to 6.4, midpoint of a line segment in space. Suppose we have given 2 points P1 and P2 with coordinates x1, y1, z1 and x2, y2, z2. Now, the midpoint of the line segment joining these 2 points is given by the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. This is midpoint formula of 2 points in space. For example, here we have given 2 points P and Q, and what we are asked is to find the midpoint of PQ. Then the midpoint will be given by 4 plus 1, 5, 5 over 2, 5 over 2, 1 plus negative 3, negative 2, negative 2 over 2 is negative 1, 7 plus negative 5 is 2, 2 over 2 is what? 1. Therefore, the midpoint of the line segment joining P and Q will be given by 5 over 2, negative 1, 1. Now, based on this, you can solve exercise 4. Let's pass to 6.5, equation of a sphere. A sphere is nothing but a collection of points. A sphere is a collection of points in space that are at equal distance from a fixed point. This fixed point is known by the name center, center of the sphere, and the constant distance is called radius. So, a sphere is a solid object, almost similar to a ball. It has a center and it has a fixed radius r. And the equation of a sphere with center at h, k, l and having radius r units is given by the formula x minus h the whole square plus y minus k the whole square plus z minus l the whole square equals r square. This is equation of a sphere centered at the point h, k, l and having radius r units. Now, let's come to the discussion of a relative location of a point with respect to a sphere. Suppose we have given a sphere and any point P on space. Now, if the distance of that point from the center of the sphere is equal to the radius, that means the point lies on the sphere. If the distance of that point from the center of the sphere is found to be greater than r, it means the point lies outside the sphere. And if the distance of the point from the center of the sphere is found to be less than r, it means the point lies within the sphere. So based on this, you are expected to solve exercise 6.6. Okay, by this we have come to the end of our presentation. If the midpoint of a line segment is M, given by the ordered triple 1, negative 4, 6, and one of the endpoints of the line segment is at point P, that is 3, 7, negative 1, then the question is the coordinates of the other endpoint of the line segment. Okay, now we have given a point P that is with ordered triple 3, 7, -1, and the midpoint of the line segment is the point M, that is the ordered triple 1, -4, 6. Now the question is to find the other end point of the line segment. Now if I let the other end point to be ABC, then 3 plus A over 2 must be equal to what? 1. 7 plus B over 2 must be -4. And -1 plus C over 2 must be 6. So the midpoint 1, -4, 6 must be equal to 3 plus A over 2, comma 7 plus B over 2, comma -1 plus C over 2. Now, in order these two ordered triples to be equal, they must be equal component wise. That means the x coordinate must be equal to the x coordinate, the y coordinate must be equal to the y coordinate, and the z coordinate must be equal to the z coordinate. Now from this, 3 plus a over 2 must be 1. So 3 plus a must be 2 times 1, 2. And a must be 2 minus 1, 2 minus 3, that is -1. 7 plus b over 2 equals -1. 7 plus 4 equal to 2 times -4 is -8. And b equals -8 minus 7, that will be -15. And -1 plus c over 2 equals 6. -1 plus c equals 2 times 6, that is 12. And c must be 12 plus 1, that is 13. Therefore, the other end point of the line segment must be -1, -15, 13. Now, the second question, let A be the ordered triple to A minus 3, -5. And B, another ordered triple, -1, 5, A plus 3. Let this be 2 points in space. If the distance between these 2 points is 13 units, the question is find the value of A. Now using the distance formula, distance between 2 points A and B is the square root of change of x square plus change of y square plus change of z square. What is change of x? 2 minus -1. What is 2 minus -1? It is 3. 2 plus 1, that is 3. 3 square, that is 9, plus a minus 3 minus 5. A minus 3 minus 5. A minus 3 minus 5. That will be what? A minus 8. So a minus 8 is the whole square, plus -5 minus a plus 3 minus a plus 3. So it becomes -5 minus a minus 3, that is -a minus 8. -a minus 8 is the whole square equals the square root of 13. So squaring both sides will have 2 plus 1 the whole square, that is 9, plus when we expand a minus 8 is the whole square, we'll have a square minus 16a plus 64 plus minus a minus 8 is the whole square. When you square this, we'll have a square plus 16a plus 64 equals 13 square, that is 169. Now, a square plus a square is to a square, minus 16a plus 16a cancelled out. And let's add the constants. 9 plus 64 plus 64. 64 plus 64 is 128 plus 9, 137 equals 169. 2a square is 169 minus 137, that is 32. Dividing by 2, we'll have a square equals 16, and the value of a will be plus or minus 4. So the answer is B. plus or minus 4. Question number 3. Question number 3. Which one of the following points divide the line segment AB where A is -5, -3, -1, and B is 9, 4, 20 in the ratio 3 to 5? Now here we have given a line segment AB, we are asked to find the point P, let the coordinate of PB, ABC, that divides this line segment in the ratio 3 to 4. 3 to 4. Now, AP divided by PB, AP divided by PB must be equal to the ratio 3 to 4. And we know that this is called proportion. And a proportion is valid whenever the product of the extremes equals the product of the means. So 4 times AP must be equal to 3 times PB. 4 times AP. If you take this as a vector, AP means it is an ordered triple that is obtained by subtracting the ordered triple corresponding to A from the ordered triple corresponding to P. So P minus A. AP means P minus A. Now P is ABC. A is this point. A is this point. So we'll have what? A minus -5, it becomes A plus 5. A minus -3, it becomes, B minus -3, it becomes B plus 3. C minus -1, it is C plus 1. This is AP. Equals 3 times PB. 3 times PB means subtracting ordered triples of P from B. B is 9, 4, 20. Therefore, 9 minus A, 4 minus B, 20 minus C. Now, let us distribute these 4 and 3. 4 times A plus 5, 4A plus 20. 4 times B plus 3, 4B plus 12. 4 times C plus 1, 4C plus 4. 3 times 9 minus A, 27 minus 3A. 3 times 4 minus B, 12 minus 3B. 3 times 4, 20 minus C, that is 60 minus 3C. Now, in order these two ordered triples to be equal, they must be equal component-wise. That means the first component of the first ordered triple, that is 4A plus 20, must be equal to the first component of the second ordered triple, that is 27 minus 3A. From this, we can calculate the value of A. 3A plus 4A, 7A equals 27 minus 20 is 7. From this, the value of A is 1. Similarly, you can find the value of B and the value of C as 0 and 8. So the point P that divides the line segment AB in the ratio 3 to 4 is the point with ordered triple 108. 108. Therefore, the answer will be D. Next question, question number 4. Which one of the following is not true about the points A and B, where A is 1, -4, -7, B is -3, -1, 5. Now, A says the distance between them is 13 units. Now, let us check. The distance between A and B is change of x squared plus change of y squared plus change of x squared. -3 minus 1 the whole square plus -1 minus -4. That is -1 plus 4 the whole square plus 5 minus -7. 5 plus 7 square. So this is 16. 3 square is 9. 12 square is 144. The square root of 169. And that is 13. Therefore, the distance of A and B, the distance between A and B is 13 units. That is okay. That's correct. Now, B says point A is 1 unit far from the x-axis. How can I find the distance of point A from the x-axis? It is the square root of what? It's y coordinate square plus its z coordinate square. What is x, the y coordinate of A? Negative 4. Negative 4 square, 16. Z, negative 7 square, 49. And that is square root of 69, 65. Therefore, it is not 1 unit. The distance of point A from the x-axis is not 1 unit. Rather, it is a square root of 65 units. So it is false. B is false. Now, C says the midpoint is -1, -2.5, -1. Let us check it. Now, midpoint of A and B, x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. 1 plus -3 over 2, -4 plus -1 over 2, -7 plus 5 over 2, -2 over 2, -5 over 2, -2 over 2. That is -1, -5 over 2 is -2.5, comma, -1. That is okay. So A is correct, B is also correct, I mean C is also correct, B is not correct. And D says point B is 5 units away from the XY plane. Distance of the point B from the XY plane is nothing but the absolute value of its Z component. The absolute value of what is the Z component of B? It is 5. The absolute value of 5 is 5. Therefore, D is also correct. Therefore, the only choice that is not correct is B. Question number 5. Let A with ordered triple for 1, 2, B. Let A and B be 2 points in space, such that the absolute value, I mean the norm of AB is 10, and the midpoint of AB lies on the negative y-axis. Now, what is the y-coordinate of B? Now, here we have given point A and point B. Point A is the ordered triple for 1, 2. And B is the other endpoint of the line segment, but its point, I mean its ordered triple is not given. Let it be X, Y, Z. Okay. Now, the midpoint of AB, it says it lies on the negative y-axis. So its X component and its Z component must be what? 0. The X component and the Z component of the midpoint are 0. Let its Y coordinate be K. So M is of the form 0, K, 0. Since the midpoint lies on the negative y-axis, K must be a number that is less than 0. Now, from midpoint formula, x1 plus x2 over 2 must be equal to 0. That means 4 plus x over 2, 4 plus x over 2 must be equal to 0. From this, the value of x will be -4. So you'll get the value of x to be -4. So the x component of our midpoint is -4. Next, y1 plus y2 over 2 must be equal to k. In our case, 1 plus y over 2 must be equal to k. From this, we can calculate the value of y as y equals 2k minus 1. So the value of y is 2k minus 1. And at last, 2, the z component of A. 2 plus z over 2 must be equal to 0. From this, the value of z will be -2. Now here we have given that AB is 10 units long. But what is AB means? Change of x square plus change of y square plus change of x, z square. Now x minus 4, the whole square, plus y minus 1, the whole square, plus z minus 2, z minus 4, the whole square, must be equal to 10. Now squaring both sides, we have x minus 4 the whole square plus, it is not 4, rather it is 2, plus y minus 1 square plus z minus 2 square equals 10 square is 100. But x is negative 4, so you'll have negative 4 minus 4 the whole square. But what is y? Y is 2k minus 1. 2k minus 1 minus 1 is 2k minus 2. 2k minus 2 square plus, what is the value of z? It is negative 2. Negative 2 minus 2 square equals 100. Now this is negative 8 square is 64. 2k minus 1 the whole square minus 4 the whole square is 16 equals 100. 2k minus 2 the whole square equals the sum of 64 and 16 is 80. So 100 minus 80 is 20. Now taking square root of both sides, we'll get 2k minus 2 equals plus or minus of square root of 20. But square root of 20 is 2 root 5. So plus or minus of 2 root 5, 2k equals 2 plus or minus of 2 root 5. Dividing everything by 2, we'll get k equals 1 plus or minus the square root 5. But we have said that k is a number that is less than 0 because the midpoint lies on the negative y-axis. So the correct choice of k will be not 1 plus root 5, rather 1 minus root 5. What was the question? To find the y-coordinate of b. The y-coordinate of b, that is y, is nothing but 2k minus 1, 2k minus 1. So y is 2k minus 1, 2 times our k is what? 1 minus root 5 minus 1. So you'll have what? 2 minus 1 is 1 minus 2 times root 5 is 1 minus 2 root 5. Therefore, the answer is D. Question number 6. Here we have given 2 points A and B as endpoints of the diameter of a sphere. The question is find the radius of the sphere. Obviously, radius is half of diameter, and diameter is nothing but the distance between these 2 points. Okay, distance is change of x square plus change of y square plus change of x square z square within the radical. So you'll have what? Negative 4 minus 1, that is negative 5 square, 25. Negative 3 minus 3, negative 6 square, 36. 14 minus negative 16, 14 plus 16, that is 30 square, 900. If you add this, we'll get 961, and obviously the square root of 961 is 31. This is the diameter of our sphere, and the radius will be half of this diameter. Half of 31 will be 15.5. So the answer will be B, choice B. Now let's pass to question number 7. Here we have given 2 points, 1, 2, 3, 6, 5, 4, and another point, 11K, 5, and they are given to be collinear. Collinear means lying on the same line. And the question is, find the value of K. Since these 3 points A, B, and C are given to be collinear, it means AB has to be parallel to BC. AB should be parallel to what? BC. And we know that if 2 vectors are parallel to each other, then one must be a constant multiple of the other. So there must be a real number T such that AB equals T times BC. What is AB? It is B minus A, the coordinates of B minus the coordinates of A. So you'll have 5, 3, 1. BC, coordinate of C minus coordinates of B. And you'll get it to be 5K minus 5, 1. And we have said that AB equals T times BC. 5, 3, 1, AB is this one, 5, 3, 1, must be T times 5K minus 5, 1. Now, if you distribute this one, 5t must be equal to 5. 5t must be equal to 5. T times k minus 5 must be equal to 3. T times k minus 5 must be equal to 3. And the coefficient, the last one, t times 1 is t, must be equal to the z component 1. From this, t is 1, and 1 times k minus 5 is k minus 5 equals 3. From this, k will be what? 8. Therefore, in order these 3 points to be collinear, the value of k must be 8. Therefore, the answer is A. Question number 8, which one of the following is true about the points of the intersection of the sphere centered at 21, 35, 20 and having radius 29 units with the y-axis? Now, first let us try to find the distance of the center from the y-axis, okay? Now, A says they do not intersect each other. B, they intersect at exactly 1 point. C says they intersect at exactly 2 points. And D, they intersect at infinitely many points. Now let me repeat the question again. Which one of the following is true about the point of intersection of the sphere centered at this point and having radius 25 units with what? The y-axis. Now, let us try to find the distance of the center of our sphere from the y-axis. Okay? It is the square root of x squared plus z squared. The square root of x squared is 21 square and y square is 35, plus z square, not y square, plus z square. And z square is 20 square, 441 plus 400, that is 841. Square root of 841 is 29, and this is the same as the radius of our circle. Therefore, the center of our sphere is at a distance of 29 units from the y-axis, and that is exactly equal to the radius, means the y-axis is tangent to our sphere, because the distance between the center of the sphere and the y-axis is exactly the same as the radius of the sphere. So we can say the y-axis is tangent to the sphere. And question number 9. If a sphere with center -7 for -5 intersects the x-axis at 13, 0, 0, and then the radius of this sphere is blank. Now, this point, 13, 0, 0, is a point on our sphere. Therefore, the distance between this point and the center of the sphere will give us the radius of the sphere. Now, using the distance formula, the distance between P and O will be 13 minus -7, 13 plus 7 the whole square, plus 0 minus 4 the whole square, plus 0 minus -5, 0 plus 5 is the whole square. So 13 plus 7 is 20, 20 square, 400, plus -4 square, 16, plus 5 square, 25, and the sum is 441, and the square root of 441 is 21. Therefore, the radius of our sphere will be 21 units. Question number 10. Let P and Q are endpoints of the diameter of this sphere. The sphere with equation x squared plus y squared plus z squared minus 2x plus 6z equals 6. Now, if P is 1, 0, 1, then the point Q is at what? At dash. What are the coordinate, the ordered triples corresponding to point Q? Now, from this equation of the sphere, we can find the radius and the center of the sphere using what? Completing the square method. Now let's collect x's together, y's together, and z's together. So x squared minus 2x plus y squared plus z squared plus 6z equals 6. Now to make this one a perfect square, I have to add 1. There is also y square, then z square plus 6z. In order to make this a perfect square, I have to add the square of half of the coefficient of z. Half of z, half of the coefficient of z is 3. 3 square is what? 9. So to balance our equation, I have to add 1 and 9 on the other side of the equation. So x square minus 2x plus 1 will be x minus 1 the whole square plus y square plus z square plus 6z plus 9 is z plus 3 the whole square equals 6 plus 1 plus 9 is 16. Now from this standard equation of sphere, we can find the center and radius. Now the center is 1, 0, negative 3, and the radius is square root of 16, that is 4. Now let Q be the point with ordered triple ABC. Now, since O is the midpoint of PQ, we have what? 1, 0, negative 3, 1, 0, negative 3, which is the center of our sphere, equals A plus 1 over 2, midpoint formula, B plus 0 over 2, and C plus 1 over 2. Now from this, we can calculate A, B, and C as A is 1, B is 0, and C is negative 7. Therefore, the correct choice will be A. Question number 11, suppose L is a line through the center of a sphere with equation x square plus y minus 1 square plus z square, and intersects the sphere. Here from this standard equation of the sphere, what is the center of our sphere? Obviously 0, 1, 0. This is the center. And what is the radius? It is 13. Now it says L is a line through this sphere, through the center of this sphere, and intersects the sphere at the point 3, 5, 12. The question is, what is the cosine of the angle that L makes with the positive y-axis? Now, first let us try to find the vector corresponding to the line, the direct line segment joining the center and this point. Now, what is this vector? It is 3 minus 0, 3, 5 minus 1, it is 4, and 12 minus 0 is 12. Now the vector that corresponds to L or parallel to L is the standard vector 3, 4, 12. So the cosine of the angle that L makes with the positive y-axis is the same as the angle that this vector makes with the positive y-axis. So cosine of the angle that this vector makes with the positive y-axis is nothing but the y-coordinates, that is 4, over the norm of this vector. What is the norm of this vector? The square root of 3 square plus 4 square plus 12 square. 3 square is 9, 4 square is 20, 16, 29 plus 16 plus what? 144. Now what is the sum? 25 plus 144. It is 169. Square root of 169 is what? 13. Therefore, the angle that this line L makes with the y-axis is given by 4 over 13. 4 over 13. Question number 12, which of the following points is outside the sphere with equation x square plus y square plus z square minus 2x plus 2y minus 6z minus 14 equals 0? Now, the first step is to write this equation in its standard form. So applying completing the square method, we'll get this standard equation of the sphere. Now from this standard equation of the sphere, we can directly read its center and its radius. Obviously the center is at 1, negative 1, 3, and the radius is a square root of 25, that is 5. Now, let us check whether these points lie inside, outside, or on a sphere. Now, let's find the distance between this point and the center of our sphere, OA. Using the distance formula, OA is the square root of 2 minus 1, the whole square, 2 minus negative 1, 2 plus 1, the whole square, 1 minus 3, the whole square. So you'll get 1 plus 9 plus 4, square root of 14, that is square root of 14, and obviously square root of 14 is less than 5. So the distance of point A from the center of our sphere is found to be a number that is less than the radius of the sphere. Therefore, what do you conclude? Point A lies inside the sphere. Similarly, after finding the distance of point B, C, and D from the center of, you will get OB the square root of 34, and that is greater than R, which is 5, and we can say that the point lies outside the circle. OC, its distance is 3, and that is less than 5, meaning C must be a point inside the sphere. And OD, not OA, OD, and after calculating its distance, you'll get it to be square root of 22, and square root of 22 is obviously less than 5, and it means that point D lies inside the sphere. Therefore, the only point from this four given points that lies outside the sphere is point B. So the answer for question number 12 will be B. So by this, we have come to the end of the discussion of worksheet 2. And if you have any question or comment, you are welcome.